All right, we made it. It's the last new information for the block. All right. So we're going to discuss actually full stoichiometry, going from any kind of unit, mass, volume, and going to any other kind of unit, particles, mass, okay? And the only new thing related to the mole island from when we talked about conversions is where the molar ratio fits in. Because that is the key to stoichiometry. You're not doing stoichiometry unless you're doing that molar ratio where you're changing from one kind of substance to a different kind. So, you're going to learn how to apply mole island to stoichiometry. So, you'll notice that the center of mole island is just a little bit different. Alright, so you have your substance A, and you're going to either know mass, volume, or particles about it. You're going to convert that to moles. You're going to apply the molar ratio. And then you're going to convert it to whatever the question is asking about substance B. Okay? So this molar ratio, that's when you change from substance A to substance B. Alright? So that's the whole point of the molar ratio. If you leave that step out, you never made the change. And then you're just doing a conversion back to a value that you probably already knew. So, again, to add numbers to go with this. So whenever you're dealing with mass, when you're going from mass to moles, you're going to need to set up that 1 mole equals the molar mass from the periodic table. Whenever you're dealing with mole and volume, it's 1 mole equals 22.4 liters. Alright, that only works at STP, but we're just going to assume we always have STP. And then if you have a particle question, you're going to use Avogadro's number. 1 mole is equal to Avogadro's number. And then, so that's the first step. Then the second step is going to be your molar ratio. Okay, so you're going to get those numbers from your balanced equation. Alright, and then your numbers should have, the coefficient for substance A in the bottom, coefficient for substance B in the top. And then the last step is your question's probably going to ask for something related to substance B. It might be the mass, it might be the volume, but the conversions that you use are the same numbers as when we did it in step 1. Okay, except your molar mass will be different because you're dealing with a different substance. Alright, so let's do some practice here. So if you have 79.1 grams of zinc to react with excess hydrochloric acid, okay, this is one way of telling you zinc is your limiting reactant. How many liters of hydrogen gas will be produced? Alright, so step 1, we need to convert to moles. So we have 79.1 grams of zinc. I want to convert that to moles. So this is where having a periodic table handy is going to be useful. And I need to zoom mine in a little bit because I can't read it. So zinc has a mass of 65 grams. Where am I going to put that to appropriately cancel things out? Hopefully you're seeing on the bottom. So I've got 65 grams of zinc, and that's going to be equal to 1 mole of zinc. Alright, you'll notice I'm writing the element names in here, and that's because it's helping me organize things, because not only do I need to cancel out zinc, but I need to cancel out grams of zinc. Okay, so grams of zinc gone. Now I'm in moles of zinc, which means I'm ready for step 2, molar ratio. Alright, so if I go to my balanced equation, I'm going to put moles of zinc in the bottom to cancel things out. And I see no number in front of zinc, so that means 1. And then it asks how many liters of hydrogen gas will be produced. So the hydrogen gas is over here. That also is missing a number, so it's going to be 1 mole of hydrogen. Okay, so there's my molar ratio. So that step is required because now what I've done is I've gone from moles of zinc to moles of hydrogen. Now, last step, I don't want to know how many moles of hydrogen I'm going to make. I want to know how many liters. So I'm going to use that 22.4 liters equals 1 mole. Where should the 22.4 liters go? Okay, hopefully you're saying up top, because I need 1 mole to go in the bottom. Sorry, not zinc, H2. I need 1 mole of H2 to go in the bottom to cancel out the previous step. Okay, so now moles hydrogen are gone, and I have converted to liters. So last thing is, now we need a calculator. So what I'm going to do is I'm going to multiply by everything on the top. So I'm going to take my 79.1, and then I could multiply by the ones, but they don't change your number at all. Anything multiplied by 1 is the same number. So I'm just going to do 79.1 times 22.4. And I hit equals, and then I'm going to divide by the numbers on the bottom. Same thing, I can ignore the things that are just ones, because if you divide by 1, you don't change your number. So I'm going to divide by 65, which gives me 27.25, or 26. So my final answer is going to be 27.26 liters of hydrogen gas. And that's because that's what I'm left with at the end, unit-wise. Every other unit's been crossed off. So let's do another one. Let's say this time instead we have 79.1 grams of HCl, and we're going to react with excess zinc. Alright, so again, this time HCl is our limiting reactant. We have way more zinc than we even need. And we're going to find the same product, liters of gas. So 79.1 grams HCl. I first have to convert to moles. So I'm going to use my molar mass. Let's see, chlorine has a mass of 35 and hydrogen has a mass of 1. So if I add those together, my total mass of hydrogen chloride is 36. So 36 grams HCl, 1 mole HCl. Alright, so grams of HCl has been canceled out. Now I'm on to the molar ratio step. So if I go to, and I want moles of HCl on the bottom, because that's what's going to cancel out my moles of HCl from the step before. But there's a 2 in front of that, so I'm going to put 2 here. And then moles of hydrogen, because that's what the question's about. And there's no number in front of it, so they're going to put a 1 there. And now I have canceled out moles of HCl. So last step, question wants me to say how many liters. So I'm going to put the 22.4 liters of H2 on top again, and the 1 mole of H2 on the bottom again. That cancels moles of H2 out, leaving me with liters of H2, which will be my final units. And now I do my math. So I'm going to start again by multiplying 79.1 times 22.4. Then I'm going to hit my equal sign. I'm going to divide by 36, hit equals. Then I'm going to divide by 2, because there's a 2 in the bottom. That gives me 24.6. And the units will be liters of H2. Okay? And before I release you on your own, what I want you to do is see if you can do this one without me walking you through it. So pause the video and try it on your own, and then start the video back up after you have an answer. Okay. So now that you have an answer, let's see if you match. So we're starting out with 45 grams of aluminum. So we have excess oxygen. And I need to convert that to moles. So aluminum has a mass of 27 grams. Alright, and that's going to be 1 mole of aluminum. So that is taking care of my grams. So now that I'm in moles, I can apply the molar ratio. My moles of aluminum have to go on the bottom. If I go to my equation, there's a 4. And the question asks about aluminum oxide, so moles of aluminum oxide are going to go on top. and my coefficient is a 2, so that's the number I'm going to have there. And that takes care of moles of aluminum. And finally, the question asks what mass of aluminum oxide am I going to make? Because aluminum oxide isn't a gas. So I'm still going to put 1 mole aluminum oxide in the bottom, but on top I'm going to put the molar mass. So I can do a little bit of a calculation here. 1 aluminum is 27 grams. To multiply that by 2 to get the 2 aluminums. And then I need to add 16 in 3 times for the 3 oxygens. And that gives me 102 grams of Al2O3. And that takes care of my moles of Al2O3, leaves me with grams of Al2O3, which is what the question asks about. So now, calculation time. Multiply everything that's on the top. 45 times 2 times 102. Hit equals. Then divide by 27 equals divide by 4. And you get 85 on the dot. 85 grams of Al2O3. Alright, so these are longer calculations. They do take some time, but they are not difficult if you stay organized. If you want to sit there and speed it up and leave off units, the likelihood of making mistakes is much greater. So if you take the 2 minutes that it requires to actually put all the units on there and get all of your numbers sorted, you'll have much better success. So, and extra credit, if you want to show me your work for this problem, please K-mail me the answer in your work, and I look forward to getting it. If you're still lost, come to help.